Okay, thank you all. Thank you for your patience. Thank you for joining us today for this webinar on curve fitting. My name is Ishwar Iyer. This is an overview webinar. So my agenda today is to give you a broad perspective of curve fitting in Origin. So let's get started. First, I want to give a brief overview of what's possible curve fitting in Origin. The best way to start that is to go look again on our website. And this time I'm going to click on products menu and click on. So this page essentially describes both Origin and Origin Pro. As you know, we have two products. The original version has more advanced analysis features, including certain curve fitting features. And over here, we have a menu to explore. So if I click on curve and surface fitting, it'll jump to a section, but I can click read more. Then it goes to a page /curve fitting /data analysis /curve fitting. This is the link that I put for you in the project. So this is a good place to come and browse to see, okay, we have linear fit, polynomial fit, multiple regression, and what are the specific highlights of nonlinear fitting, surface fitting, and so forth. And we also have apps. Okay, I'll come back to apps in a moment. So this is a good place to view an overview. And as I said before, some features are only in Pro. So whenever you see this little icon Pro, that means, for example, compare models and datasets or surface fitting is only in Pro. If you click the icon itself, it'll take you to a page that will list the difference between an Origin and Origin Pro in various areas. Okay, so the top is curve fitting. So here you can quickly compare what's available in Origin and what's available in Origin Pro. So several features are missing in the standard version, which are available in Pro. So this may be a useful resource for you as well to review what we have. Coming back to the product, okay, let me now show you where in the GUI are the various locations where you need to go to find curve fitting related tools and gadgets and apps. So we have several ways of approaching curve fitting. So let me make a worksheet active, show you the menu. So now if I click on the analysis menu, you will see there is a fitting menu entry, and there's a flyout for linear fit, fit linear with X errors, polynomial fit, multiple regression, nonlinear fit, implicit curve fitting, and so forth. Okay, quite a few entries here. Okay, and keep in mind, I am using Origin Professional 2020B, the latest version and the Pro version. So if you have standard version, you may not see these many menu items. Okay. At the end of this menu, there is also a find apps. Click that. So what that does is it opens our app center. You may already know that we have been publishing free apps for Origin for quite a few versions now. There is an app center docked on the right side of Origin. And when I chose that particular menu, it opened this App Center tool with the search tab active and the keyword fitting already populated in there, and the search has been performed. So you can see here that we have added many apps related to curve fitting. Okay, so rather than populate everything in the product, we have put them into the App Center so you can download the ones that you want. So the ones with the green check marks, I already have downloaded. The ones that are waiting, for example, standard curve analysis, if I click on this download button, it'll download and install that app. So that's the idea, okay? Keep in mind that each app also has a minimum version requirement. So the one I'm downloading right now requires 2020B, okay? Whereas some other apps such as Sequential Fit only requires 2018B and so forth, okay? So you see, I downloaded that and the standard curve icon showed up immediately in my App Center. So that's the idea with apps. Okay. In addition to that, we also have some gadgets. So one thing you may already be aware, when you switch around window types in Origin, the menu changes slightly. So now I am in the worksheet mode. Now I go to graph. Now you see a gadgets menu appears. Gadgets were introduced many versions ago before the idea of app came around. So there are a few gadgets here, quick fit, quick sigmoidal fit, etc. I'll show you the quick fit gadget a little later. Okay. So essentially we have the analysis menu with the fitting options, and keep in mind the flyouts and the menu slightly change depending on whether a graph is active or a worksheet is active. Not only the main menu changes, but what's in the flyout may also change. Okay? So you need to get a little familiar with the menus. Okay? Then we also have past webinars. The page I showed you, we have an advanced curve fitting webinar. The recording has been put up there already. That was done many weeks ago. We have a specific webinar on defining your own fitting functions. If you are interested, you should attend that. I'm going to show some quick example today. So just to point out, there are more webinars about curve fitting that you may want to review. Okay, now let's jump into some specific exercises. Okay, so the simplest way to perform a fit in Origin in recent versions is to use the Simple Fit app. This app was introduced many versions ago. It's an app that's pre-installed with Origin. So if you buy Origin tomorrow and install it, the app will already be there. You don't need to go get it. Okay, of course, there is an update that happens. The App Center shows you the app will have a little red dot, like I have a red dot here, which means there are some apps available to date it. None of these need an update. So you can all dating when we improve the app. So with this data set, let me simply fire up the Simple Fit app. The dialog comes up, and there are options for doing linear fit, polynomial fit, or nonlinear fit. As soon as I chose linear, you see that the linear fit line has been placed there. I can do things like fixing my intercept or slope if I so desire. Okay, I can turn on like 95% confidence band if I want to, and simply click report. Okay, that dialog closes, and I get a report sheet here. We'll spend a little bit more time with the report sheet later when we do LR and nonlinear fit from the menu. Anyway, this is a detailed summary report. Not just fitting, statistics, many other operations create reports like this in Origin. Okay, there are embedded graphs in there, such as the fit graph and the residual plot. You double click to open it. You can view it, make changes, put it back. Okay, let's now do a nonlinear fitting with the same Simple Fit tool. So here I have a Gaussian distribution. Okay, and there are many functions in Origin for performing peak fitting, but what if I want to define my own function? So I'm going to go to Wikipedia, to this page, to look up what's the definition of Gaussian function. So here is a definition: A times exp of minus x minus b squared over 2c squared. Okay, I have already copied that in a form that can be put into the dialog in a simple text form. So let me copy that. I only need the right side part. And with the graph active, I'm going to fire up the Simple Fit tool now. Okay. Then I can go to nonlinear fit, and I can even use existing functions. Origin ships with many, many categories and many, many functions, about 150 to 200. I lost count. But what I want to do is define my own. So let me uncheck that, and I can go here and put my expression. Okay, Control V, that's my expression. The moment I click outside the box, Origin will parse it. It assumes that the function is of the form f y equal to f of x. So anything else that's not x here is assumed to be a parameter. This tool doesn't do a good job of initializing values, so it's just randomly assigning 1 to all the parameters. So A here is amplitude. So let me go ahead and change that to 100. You can see that changed my curve. B is the centroid. So my centroid is roughly around 25, looking at the graph. So my curve shifted. Let me change my width to about 5. So that's a good initial value for fitting. Then I can do either one iteration or click the fit button to perform fitting. And then I'm told the fit converged, the nonlinear regression happened. The adjusted R squared is 0.97, which is pretty good. Then I can click OK, and get my report. So this is a quite useful tool. And if you're doing a very quick fit, just to explore different fit functions and such, this may be all you need to begin with. So I wanted to show that first. Any questions, comments? I may be speaking a little too fast. Let me know. If time becomes a crunch, I will skip some of these topics, and you can, of course, do previous webinars, and we have quite a bit of all of this covered in previous webinars as well. Okay, keep your questions and comments coming. Okay, now let me switch to using a gadget for fitting. So here I have a graph. Let's say I have measured rate of a reaction, maybe as a function of time, and maybe around time equal to 5 minutes, I introduced a catalyst and the reaction rate changed dramatically. So, okay, somebody commented that the Gaussian did not fit the tails well. So the nonlinear fit, I did not spend much time in setting the limits or fixing the parameters and such. I'll show you more examples of that later. The fit, by the way, is iterative. It wiggles all of the parameters and does the best job of finding minimum chi-squared. So depending on your data and your model, if you do not apply any constraints or bounds, what you get is what you get. Okay, coming back to this, I want to find the slope in phase 1 before the catalyst and phase 2 after the catalyst. So I want to do a region-wise analysis. There are many ways to do that in Origin. I can set a data range and then fit. I will show you examples of that later, but let me first go to gadget. Okay, and under gadget, I go to quick fit, and let me choose the linear theme. There are many others. You can do fitting with non-linear as well. So here the idea is I get a region of interest, what we call an ROI for short. So I can move that around, and it's dynamically performing the linear regression on those data points that fall within that rectangle. Okay. Now, if I click on this little triangle button, there is a menu here. I can go to preferences and change things, whatever I want to customize. So for example, on top of the ROI box, I can say, show what to show. I'm interested in the R square value. And you can even show a parameter list if you so desire. Intercept slope, I'm not so interested in the x-intercept in this case, so I turn that off and click OK. And now you see that changed, and it's telling me my R squared is 0.99943. Looks pretty good for phase 1. I can go here and also choose where should the output go, okay, the report go. Report can go to results log, it can go to script window, or it can go to a worksheet. Let me just choose worksheet and click OK. Then I can click on this button and say, give me a new output for this range. Okay, so it spit that result out into a book. My result, okay, equation and the weighting and the intercept and slope error and everything. And it also put a label on my graph. Then to the right side and pick some points safely in the second phase. This is a transition area, so I'm skipping those points. And then I click again and I choose new output. Okay, then I can close my gadget. So with a few clicks, I did a quick analysis of phase 1 and phase 2 and got my notes here. I can further edit the label if I'm interested. And I also have a worksheet with all my results. Okay, so that's the nice thing about gadgets. Okay, let me show you one other example with gadgets. Okay, so here I have 3 decay curves. Okay, I'll do nonlinear fitting a bit later. What I want to do is stick with linear fit for now. And I just want to fit the tail end of all of these curves with the linear fit. Okay, so let me bring up the gadget again, quick fit and the linear option. And I'm just going to position it at the tail end. It's already there. And you can see the fit line is shown on curve 1. I can click here and change the data to curve 2 to see how that looks. I can change it to curve 3 and so forth. Everything looks good. I can go to preferences and decide where my output needs to go. Okay, so for my result output, I can say worksheet, and I can call it quick fit 2, quick fit book 2. Okay, then watch here. If I click, I not only have new output, I also have new output for all curves. So let me choose that. So what it does is it applies the gadget ROI to each curve in the layer. Okay, and my analysis is done. Then I can click here and I say go to report sheet, and I can close this. Okay, and if you look at the report sheet, you will get the linear fit to the tail end of all of those exponential data sets. Okay, so you can not only analyze a single data set, you can analyze multiple data sets. In fact, if you have a graph with many layers, you can handle that too. Okay, so check out the gadgets. Again, this is a simple approach. If you want a quick fit, you're not really interested in a detailed report or changing the analysis parameters or anything. So simple fit and gadgets may be a good choice to start with. Okay. Now let me move on, and I'm going to start working with the tools from the menu, which are a bit more rigorous. Okay. So in this graph, I have some absorbance data as a function of concentration. So maybe it's a chemical with different concentrations, known samples. These are samples known to me. I know what the concentration is. I put them in the spectrometer, measured the absorbance peak, maybe the area, maybe the height, whatever. And I have plotted that, and it looks linear, and I want to do a calibration curve, fit this with a linear fit. And my goal is twofold. One is to fit, and the next is to predict. If somebody walks up to me with an unknown sample, I pop that into the spectrometer, I get a new Y value, which is the absorbance value. From that, I want to predict the concentration, so I know what is the concentration of the unknown sample. So that's my goal. So with this graph active, let me go to analysis, fitting, okay, and open the linear fit tool. So this is the more rigorous tool. Okay, there are many tabs and options in this tool. To begin with, let me just click OK. Okay, so that the default options. Let's see how that works. So Origin says the analysis has been performed. Do you want to switch to the report sheet? There are choices here. These kind of dialogues, you can say yes, or yes, do not bother me, do the same thing again, or no, and don't bother me again. Let me choose yes. And then you'll see that in the worksheet, it added a nice report sheet, okay, with all of the information here. Let's spend a little time looking at this report sheet. So at the top, you have a notes node, which tells you where the data came from, who did the analysis, the login name, what time it was done, okay, all that. And then what was the input data, what were the specifics of it, was there any masking done? Okay, we cover masking in the advanced analysis. Were there any missing values? Then here's a parameter table. It's telling me what the intercept values are, the standard error, the t-value. Okay, then the detailed statistics, how many points were there, what were the degrees of freedom. I'm fitting with a function with two variables, so 5 minus 2 is 3. The residual sum of squares, adjusted R squared. Then this is the parameters in a turned around transpose summary. Okay. Then an ANOVA table and a key statement under the ANOVA table. At the 0.05 level, at the 95% confidence level, is the slope significantly different from 0 or not? That may be useful if you are looking for a quick linear correlation. By the eye, it may look like there is a correlation, but statistically speaking, you have to look at under the ANOVA table to see, is there a significant difference in the slope from the value of 0? Okay, quite useful information here. There's also a nice 4-panel residual plot, okay, whether the residuals are normally distributed and all that, okay. Let me go back to the graph. One thing you will notice that's different from simple fit or gadget is that when you do a more formal analysis, Origin puts a lock on the output sheet as well as on the graph. The idea of this lock, what we call in general as recalculation lock, is that you can click on it and do several things. One of them being change parameters, another being go to the source, third being go to the results, okay? You can set the lock to be manual mode or auto mode. Auto mode means if the data changes, the operation will automatically update. We have several webinars, videos, tutorials on all this, how to work with automating your analysis. So I'm not going to spend time on the automation part. Let me do change parameters. The idea here is it'll bring up the dialog in the exact same configuration that you left it last time you closed it. So this way you can keep fine-tuning your analysis. Go back, change some parameters, look at the result, open again, change again. Allows you to explore and refine your analysis. So this time around, what I want to do is, I'll just quickly click through here. Fit control, there are options here to fit intercept or slope, quantities to be computed. Do you want lower upper confidence levels? A lot of control. Residual analysis, do you want studentized residuals? Fitted curve plots, there are options there. My specific interest right now is find XY. So like I told you before, somebody brings me a new sample. I know the absorbance, which is Y. I want to know the concentration, that's X. So I want to do find X from Y. Okay, if I check that, you'll see there is another checkbox saying calculate the confidence interval as well. Let me check that. The other option is find Y from X. That's trivial because once I do a fit, I can just compute Y from X from the fit line. Okay, my interest is I know the Y, I want to find the X. So let me click OK. So what that essentially does is when I go back to the report sheet, to that book, it has added a new tab here. And it's waiting for me to enter new Y values. So this is where your colleague walks up with an unknown sample, you pop it in the spectrometer and it gives you a measurement of say 0.345. You click OK. Origin is telling you that based on this linear regression, the X value, the concentration of that sample is 0.57215, and there is the confidence level, it's quite broad, okay? Because the fit is not that good, okay? So I can keep entering, it's just the nature of the data, okay? Maybe a linear fit wasn't very appropriate for this. So you can see I can enter new Y values and I can keep getting the X values that are predicted along with the confidence levels. So hopefully this is useful, particularly for you chemists out there, okay? You can then play around and add this data back into the graph to annotate your unknown samples. I'll leave that as a graphing exercise for you. We have many graphing examples and webinars and tutorials and videos on YouTube, etc., that you may want to explore. Okay, let's now move to nonlinear fitting. Okay, let me take a moment to look at the questions. I don't see too many Q&A here. I hope my pace is okay. Somebody commented it's fine. Thank you. So keep your questions coming. So I already did some fits from the graph. Let me quickly show you a nonlinear fit from the graph with a simple data set. So here I have a dose response curve and I want to do a dose response fitting. So let me now go to the analysis menu, and this time under fitting, I'm going to choose nonlinear curve fit, okay? Note that there is a shortcut key, Control Y. Nonlinear fit is quite popular, so you don't have to keep going to the menu. You can simply hit Control Y. Let's spend a few moments on this dialog. It's a rather complex dialog. If you are a new user to Origin, you may want to watch some beginner tutorials on how to use this dialog. We keep adding more and more options and bells and whistles because customers keep asking us, and there is no way to hide some of the complexity. We have tried to organize it the best way we can. So the first thing you need to do here is under settings, you have to pick a function. Like I mentioned before, Origin has many functions which are organized in categories. Okay, so this time around, I am going to choose growth sigmoidal category. And then the function dropdown will change. And in my case, a dose response function is suitable. Okay, so you will notice that the moment I chose the function, Origin already placed an estimated curve. With all built-in functions, we look at the data and the function formula and try to guess the parameter values. We have algorithms for doing that. Okay, they may not be perfect, but works 90% of the time. So the guess looks pretty good here. I can go in here and do things like, do I want to fix the asymptote to a particular value and such? I'm not going to spend time on that. That's covered more in the advanced webinar. So let me just go back to the settings tab and just show you under data selection, Origin picked up the input data from the graph. Because I started from the graph, there was one layer with one curve. So Origin automatically said, oh, that's the curve you want to fit. So that's how everything works smoothly. Okay. Let me, for now, we'll come back to this dialog for other example. Let me for now hit the fit until converge button. You'll get a clear message here saying how many iterations were performed, did the fit converge, what's the reduced chi-squared values, what's the COD, R-squared value, and then you can look at the residuals to get a rough idea of how the residuals are distributed. Doesn't seem skewed, or it seems pretty good. So also with all these functions, we also show a preview of the formula and the sample curve, what each parameter means graphically and such, and so on. And once I click OK, the fit is performed and I can switch to my detailed report sheet. So similar to how I showed you the detailed report for linear fitting, you have a similar report here for nonlinear fitting. And you have the lock, so you can click on the lock and do change parameters and open it, and you can decide whatever you want to decide at this point to make changes and update the fit. Okay. Let's talk about starting from a worksheet. If I start from a worksheet, I can do a couple of things. One is I simply hit Control Y to open the nonlinear fit. And in this case, it happens to be a Gaussian data set. So let me just choose Gauss. Okay. And then the tool is reporting to me that data for fitting has not been specified. That's because I made no selection in the dialog, in the worksheet before opening the dialog. So I can come to the data selection tab, and here I can click on this flyout, and then I can say add the amplitude column. It will pick up all the Y columns. Okay, that's one way to do it. Another way is if you select the column to be fit, it can be more than one column. I'll show you later. Then I hit Control Y, Origin will automatically take those selected columns as the data. In my case, only one column was selected, so it already preloaded that data. Then all I need to do is to select my function. In this case, the Gaussian function. I can simply click fit. Everything will get done, and then I get my report. Okay. But how can you pick which function is suitable for your plot and nonlinear curve fitting? I'll come to that a little later when we talk about rank models. Okay. Multiple data sets. So here I have multiple data sets plotted. Let me stay with the graph, and I want to fit the data with exponential decay function. Okay. So with the graph active, let me press Control Y. Okay. So I want to choose a function, go to the exponential category, and let me choose exponential decay 1. And if you look at the sample curve and the formula, it's a one-term exponential decay. Okay. And if I now look at the residuals, go to data selection, one thing you will notice that it picked up only one data. Why is that? So Origin has this concept of an active data plot. So if you have a graph with multiple layers, in my case, there is only one layer. There is only one layer active. If you have 4 layers, out of the 4, only one would be active layer. Okay. And within the active layer, if you have multiple data plots, one of the plots will be the active plot. So Origin by default assumes you only want to fit that particular data plot. But in my case, I want to fit all of them. So I can click here at the input level, not at the range level, at the input level, and I can say add all plots in my active page or add plots in my active layer. In my case, it doesn't matter. There's only one layer. So if I do that, you will see that it picked up all 3 ranges. And if I nudge the dialog over, you will see that it put sample initialized fit curves on all 3 data sets. Okay, so just so you know, starting from a graph, you need to watch out for selection of data. So if I now click the fit, it's fitting actually one data set at a time. So that's data set 1. I can go to then data set 2, etc. Or here I can choose all and say fit them all. Okay, and if I then click fit converge, it did a fit. I see that perhaps for these 2 data sets, the fit doesn't look that good. So I can go back to my function selection and let's try a 2-term exponential decay. Okay, xdec2. So the difference here is in the formula, there are 2 decay terms. Okay, then let me click fit all again. And then if I move over and look, that's a much better fit. And let me click OK. So what Origin did in this case is it took multiple data sets, fit them one at a time. Okay, so we call it individual fits, but the report is consolidated. So if you look at the summary table, which is easier to look at, let me first show the statistics table. So for each data set, it is showing me a different adjusted R squared, you see, because each curve was fitted separately. Okay. And if you look at the summary, you will see that the values are all reported separately, okay, for each curve, okay. So, but the report is consolidated. So if that's what you want, if the data should be fit one at a time, so this is what you do. Let me switch to global. I'll come back to concatenated fit after global fit. What if I want to fit them by sharing parameters, okay? So that's where global fit comes in. So here I have a graph. I have 4 Gaussian shaped data sets. I want to fit them all, but I want to share the width parameter. Okay, that's global fitting. So let me press Ctrl Y to bring up the fitter. And this time, let me again go to data selection. And as you saw before, Origin picked up only one curve because it picked the active layer, which happens to be layer 3. And there was one plot in that layer. It picked that one up. But I can click here and say, add all plots from the active page. So it will pick up from every layer. I have 4 layers, and each has one data set. So it picked up 4 ranges, so to speak. Okay. So now it's waiting for me to decide a function. But before I do that, in data selection mode, you'll see there's a multi-data fit mode dropdown. If I click on that, you'll see the default is consolidated report, which is what we saw before. Independent fit consolidated report. That means fit each curve independently, put it together in one report. You can have independent fit separate report as well. But my interest here is global fit. Okay. If I choose global fit, let me choose a function. In my case, Gaussian function. If I choose global fit and go to the parameters tab, a new column will appear called share. So the idea here is I can share parameters. Okay. Let me make this dialog. Let me close the bottom panel and stretch this dialog a bit. So now you can see there are parameters for each curve, but as said before, I want to share the width parameter. So the moment I click on width, you will see that the width disappeared from the other data set. So the idea here is the width is only one parameter that is going to be shared among all data sets. So let me then do the iteration. Okay, nudge my dialog to the side. Things look good. Fit looks good. Click OK. And now let's go to the report sheet. Okay, once the fit is done, I can switch to the report sheet. And let me show you now the summary panel. Okay, if you look at the summary panel, now you'll notice that the width parameter reported is all the same. You see, value and error. That's because the global fit was done by sharing parameters. Okay, we have some apps for doing global fitting even with different functions and share the parameters. Okay, so you may want to check that app out if you are if it applies to you and if you need to perform global fitting. Okay, let's go look at one more mode, which is concatenated fit. Okay, in this case, I have here again a dose response fit. I did 3 measurements, 3 experiments on the same sample. Okay, so I have 3 different measurements and I want to fit them. I don't want a global fit. I do not want an individual fit. I want a replicate fit where I want to combine all the data together as a single data set. So for that, let me bring up Control Y. Okay, let me first choose the function. Okay, growth sigmoidal, and I'm going to choose dose response. Okay, then let me go to data selection. Again, the same issue that it picks up only one. I can go here and say pick up all from the active page. Okay, and this drop down becomes available. And here you will see I have a concatenate option. So the idea with concatenate is take all of the data, club it all together into one single data set internally and fit with that. Okay, now at this point, if I simply do a fit, it will show me, function selection, dose response, data selection, response 1, concatenate 1, 2, and 3. And there are other options here for setting the report to be only standard deviation and mean instead of plotting a raw curve and such. I'm not going to spend much time on that today. You can look at advanced fitting webinar for more on that. Okay, so that's with nonlinear fitting. Let me now go to specifying X range. Earlier we saw that I took this data set that you saw before and did linear fit with gadget just to the tail part of the data. Let me do that rigorously with the linear regression tool. Okay, or perhaps let me do that with the nonlinear fit tool. Let's say I don't want this part of the data. I only want starting from 0.2 to 1 and fit that with exponential decay. So there are several ways to do that. One easy way is to click on this button on the tools toolbar called selection on plots. So if I click on that, there are 2 choices: select on active plot, select on all plots. So I'm going to choose select on all plots. And then I'm roughly going to draw a rectangle here to select my region of interest. When I do that, Origin places these markers on the graph. It says, okay, I understood. You have told me a certain subsection of your data needs to be analyzed. Now let's click Control Y. Now let me first choose the function. I'm just going to choose a single term exponential decay. And let's go to data selection. Okay. Now you see Origin has already put curves for all 3 data sets. This is because I explicitly marked the range for each data. Then Origin says, okay, I see you have marked 3 different curves, so I assume you want to fit all 3. Okay, so if I expand the input data, you will see there are 3 ranges. Let me expand it a little further. Then you will see there is details here. It's restricting from row 21 to row 100. I can change that to be by X, and I can say precisely from 0.2 to 1. Okay, I can do similar things for the others. I can click here also and say apply row range to all. Okay, then if I expand this, so if you have 20 data sets, you need to do that only one of them, and you can just use that menu. Again, I'm going rather quick with all of this. There are tutorials on this, videos on this, so you can explore those for more details or play back this recording when you get the recording next week. Okay, then I can click fit, and it's going to do the one-term exponential fit only from x equal to 0.2 to x equal to 0.1. Okay, exactly that range. Okay, hope that was useful. Okay, let me see questions here. I see my colleague Shao is helping me answering questions. I see a question about how to fit a broad line which is made of three curves, a Gaussian and a Lorentzian, not a listed curve. So there will be a peak fitting webinar later today. So let me not spend more time on peak analysis in this webinar. You may want to attend the peak fitting webinar. I also want to say our excellent tech support team is always there to help you. Just email them and tell them, hey, I attended this webinar. This particular topic wasn't covered. Here is my data. I need help doing yada, yada. And they will be more than happy to help you out. Okay. I'm a bit limited on time here. I have about 15 minutes and a few more topics to cover. Rank models is something I would like to cover. So let me try to at least get to that. So let me move on with a few more topics. Okay. So how about fitting with error bars? So here I have a Gaussian shaped data set, but I have Y errors. I have already plotted them. As you know, in Origin, in the worksheet, you can right click on a column and set as X, Y, Y error, X error, and such. Okay. So I have already set it. I have plotted. Origin recognized that column as error, and it plots as error bar. So now if I click Control Y and choose the Gaussian function, okay, and then go to data selection, there is obviously only one range. But if I expand the range, you'll see that under Y, it now says there is weighting, and weighting is assumed to be instrumental, that is 1 over the value square. Origin assumes that to be the default. Okay? But if you click there, you'll see we have many different weighting options. Okay, arbitrary data set, direct weighting, which would be directly proportional to directly scaling based on the error values in a column rather than 1 over value squared. Okay, statistical weighting, which would be there is no error bar, but you want to use 1 over Y as the weight. Okay, variance-based weighting. There are several methods here that customers have asked and we have added. So you need to figure out what's the appropriate weighting for your data. Okay. In my case, instrumental is fine. So I can click fit and then my fit is done, taking into account the weighting values. Okay. So if I go into report and if I look under input data, it will say that there was weighting used. Okay. Weight type used. X, of course, has no weighting. Y had instrumental weighting of 1 over EI squared. Okay. All right. Let me see. Other questions? 2D slice of a 3D data. Okay, that's a little outside of context of this. I see my colleague already answered. Okay, let's look at another example. What if I have X and Y error? Okay, so I have a measurement where there is uncertainty in both the X and Y values. Okay, traditionally, nonlinear curve fitting is done typically in most products with Liebenberg-Marquardt algorithm. Okay, or some variation of that. Nonlinear fitting is iterative. All the parameters are jiggled till you minimize your chi-squared. What Liebenberg-Marquardt does is to minimize the vertical distance, or rather the positive sum of squares or the vertical distance between the data point and the proposed fit line. Okay, But a more appropriate algorithm in general, and in particular when you have variations in both x and y, is orthogonal distance regression. We added this many versions ago in Origin. That's something available only in Pro. And I apologize, I did not point out explicitly what's available in Pro or not earlier. You can find those details on the website. So here, the orthogonal distance from the data point, the perpendicular distance from the data point to the proposed fit line is optimized, minimized, rather than only the vertical distance. Okay, so here I have both x and y errors. So let me simply hit Control Y to bring up the dialog. And I'm going to just choose the exponential decay function. Let me try to make this dialog a little smaller. You see it already placed a curve there. And let me do fit till converge, and I see a pretty good fit. Let me look at the messages tab down here. So it says the COD is 0.99866, but this fit now is only accounting for the Y error. Okay. Right below the function, you'll see there's iteration algorithm. The default is Levenberg-Marquardt. But if you have professional version, you also get orthogonal distance regression. The moment I chose that, Origin is going to consider also the X variation. So watch this curve and I do fit till converge. You see that the curve shifted. So now it's taking into account both error in X and error in Y. And my COD value is a little different, but the curve parameters and the curve shape change. So that's what I wanted to point out, because both errors are being taken into account. Okay. So this would be useful for you if you have measurements where there are errors in both X and Y. Okay. I do not have time to cover implicit function fitting. So we do have that, and it's covered in the advanced webinar. If you go under fitting, there is a nonlinear curve fit, but there is also nonlinear implicit curve fit. So that would be useful for fitting functions of the form z equal to f of xy. For example, an ellipse, fxy equals 0. Okay, ellipse with x and y error bars. So we have tutorials of that, and it's also covered in the advanced fitting. I'm going to skip bounds and constraints. Okay, I don't have time for it today. I showed you a little bit where in the dialog that you can fit parameters and such. You can also place bounds and constraints. This is covered in the advanced curve fitting webinar. The recording is already on the website and YouTube. You could simply go to YouTube, like I showed before, skip right over to the bounds and constraints section and watch that. Okay, let me go to rank models and show a couple of other apps, and I'll close with that. Okay, so earlier we had the question, how do I decide which function is good for my data? That's actually the wrong question to ask. The more appropriate question is, among the functions I have tried, which is the best function for my data? If you fit one data set with one function, there is no good statistical answer to say, is this a valid fit? The more appropriate question is, I have 2 or 3 fits. Which one is statistically appropriate? So let me illustrate that. So here I took some data and performed 2 exponential fits. I have already done the fits. I did one with the single term exponential. I did again with the same data with the 2-term exponential. So you'll see here the earlier R squared was 0.985. The second R squared is 0.99748. So this is better than the first one. But do I stop here? Do I add a 3rd term? Do I add a 4th term? When you add more and more parameters, you're allowing the curve to wiggle more and more, so it can get closer and closer to the data point. But is it justified? Can you really justify a 3-term fit to this or a 4-term fit to this? So to answer that question, you have to do statistical testing. So we have an app called Rank Models. It's available only in Pro, and it's already pre-installed with Origin. So I selected my raw data and I click Rank Models. Okay, I bring up the dialog. And then in this dialog, how it works is first you have to choose a category. It doesn't make sense to fit the same data with peak function and exponential and linear and model and everything. We didn't think that was a smart idea. So we ask you to first choose a category. Okay. Then you can choose the function. So in my case, I really want to compare X deck 1, deck 2, deck 3. Okay. Then I want to say, show me adjusted R squared. Okay. Then let me click the apply button. So what Origin will do in this case is it's taking the functions that I chose and it's fitting them one by one. Okay. And then at the end of it, it's going to summarize for me in the table certain information. One is the status. Status 100 means succeeded. As I mouse over, you'll see the literal meaning of that. The next two columns, the last column is the adjusted R squared. You see, they all kind of look good. Okay. But you see from exponential decay 2 to exponential decay 3, actually the adjusted R squared got a little worse, not a little better, but in the 5th digit, cannot really say what's good or bad in that context. But what's more important is a statistical measure. These two measures, these are called Akaike information criterion and Bayesian information criterion. You can look at our documentation to see algorithms on what these exactly mean. But these quantities allow you to compare across multiple fit models. And the idea is the lower these values, the better the fit. I would go with BIC over AIC. This is a more modern parameter. So this clearly says exponential decay 2 is the appropriate fit for my data. Do not add one more term. It's not warranted statistically. Okay. So I hope that answers your earlier question. How do I decide which function is good for me? That's not the right question. The question is, I have fit with 2 or 3 functions which are acceptable for this data in my field. I want to pick the one that's statistically the best. So that's the more appropriate question. I hope this was helpful. Then if this tool is helpful, if I click now output all, and then close the dialog, it will then give me a detailed report of the results from each of the fits and that ranking summary and such in the same report. The rank results are shown here. It's sorted by BIC and you can see X deck 2 is at top. Okay. Okay. Let me see. Somebody's asking what is AIC and BIC. Again, you can Google that. You can also look at our documentation for the details. Okay, there are several products that do this, not just Origin. Somebody's asking, isn't F-test better? F-test can only compare 2 fits at a time. Okay, it's sort of like doing t-test. You cannot do multiple t-tests on multiple columns. F-test can compare A to B and compare B to C. But you cannot do that multiple times and arrive at a conclusion. So AIC and BIC are more modern and they help you rank any number of fits and find the best fit. Okay. All right. I want to end with a couple of quick fitting apps. Like I showed you way at the beginning of the webinar, there are many apps that we have published for curve fitting that you may find useful. If you open the App Center from the app bar and type fitting and do a search, you can type any keyword here, okay? And you will find all the apps that are relevant to fitting. You can explore them. If you click on any particular one, it will open the web page to read more and download and try them. And we want your feedback. These apps are made mostly based on feedback or requests from users like you. I want to show 2 of them today to end with. And after that, we'll have a quick poll. And I request that you stay around for a minute more and please answer our questions, because with the polling, we would really get your feedback on how this webinar went, what should future webinars look like, what topics are you interested in, and such. We'll come to polling in a minute. First, let me look at this data. I have what is called a 96 well plate data, which is common in life science. A measurement done on 96 wells in a plate. So I have 96 XY data pairs. I want to perform a quick fit to it and get my parameters. So we have a tool called Speedy Fit. I'm not interested in very detailed reports and ANOVA tables and residuals and all that. I just want to fit. So let me click Speedy Fit. It works on the entire worksheet. So it assumes that all the data in the worksheet needs to be fit. Here again, similar to simple fit, there is linear, polynomial, and nonlinear. Let me choose nonlinear. And under category, I'm going to choose exponential. And under function, I'm going to choose stay with asymptotic function. Okay, so it's showing me the first data set and the curve. If I click fit, it shows the fit. I go to next data, click fit. The fit is bad, just so happens the well data of that particular well was bad. Something went wrong there. Next data set, fit, looks good, converge, next, looks good, and so on. So you can play with it one data set at a time, or at the end, you can decide what summary parameters do you want to report and simply click OK, and it's going to fit all 96 in a jiffy. That's why we call it Speedy Fit. Okay. And then you get a report sheet where all the parameters are listed. But what is nice is you also get a graph, an embedded graph. I double click to open that. Okay. Let me take this table and move it a little over here. I'm not too interested in the table right now. Okay. There are ways of customizing tables after fitting and such. There are tutorials and FAQs on that. You can search those. But what's cool here is I can flip through and look, okay, how my data is evolving over the different wells in my 96 well plane. So it did a really fast fit of all of the data, and I have a nice summary and a tool to explore my results. Okay. One last app sample, okay, is Piecewise Fit. I have some data here which transitioned. Maybe again, similar to the rate experiment that I showed earlier, I have a linear rate, something changed, and the parameter I'm measuring started decaying from that point. I want to fit the first part with linear and second part with the nonlinear exponential decay, but make the curves join nicely rather than do separate fits. So for that, we have a Piecewise Fit tool. Let me launch that. You can do up to 3 segments. Okay, so for segment 1, I can use an existing function or I can type in my own function. I'm going to use the polynomial category and choose the line function. Okay, and then for function 2, the second segment, I'm going to choose exponential category and a single term exponential decay function with no offset, because my offset is the point where things meet. Okay, so you see there is a simulated curve that Origin puts in there. I can click fit. Now it says my COD is 0.998, everything works fine. I click OK, the dialog closes, and you can see the final fit curve. Okay, in this case, I can also control where my transition happened. If I happen to know that the transition should be exactly at time t equal to 5 or whatever, I can adjust that as well. Okay, that didn't go well. Maybe that wasn't a good parameter value. Okay, so anyway, you get the idea that with the piecewise fit, you can take a data and fit up to 3 segments with different functions, and Origin will find the offset point and match the fit curves at that point. Okay, so I hope that was a good summary, overall overview of curve fitting in Origin. I apologize if it was very fast paced, and my idea was to cover a broad set of tools and apps and gadgets so you get a big picture view, and then you can go back to the recording and then play with the recording and get this very same project and then work with the data. Okay, and then when you run into trouble, we are here to help. Reach out to us. So please take a few moments to answer the poll. And thank you for your time today. And we hope to see you at a future webinar. There is a 2 p.m. webinar today on peak analysis. And the next set of webinars will be next Friday. I'll pause the recording, but I'm going to leave the Q&A and chat open so you can continue to ask questions. Somebody is asking, how can I perform piecewise fit with more than 3 segments? Please send us your data. We can code a function. We can also look into improving the piecewise fit to add more segments, but we thought 3 was reasonable based on data that customers had sent before. So please send us your data to tech@originlab.com. So you can email any technical questions as a follow-up on this email, on this webinar, to tech@originlab.com. Just say in your message you attended the curve fitting webinar, and then you have a follow-up question. Here is the data, help me. And our excellent support team will reply to you. As I mentioned earlier, there was a webinar on defining your own fitting function, but we also have an app which is called fitting function library. So if I type library and do a search, you'll find that app. You may want to check that out, the fitting function library. Let me click here to open the web page. We, rather than add possible function and variations of that to Origin itself, we have been adding more user requested functions to our website. And what this fitting function library app will allow you to do is look at functions that are available. And if you find one that you like, you can download and it gets added to your Origin. You can also request a function from here. Of course, you can directly contact tech support as well for that. So our idea is to add more fitting functions to this library rather than load them all up into Origin itself. Okay, I see polling has ended. Thanks a lot for joining us today. You all have a nice day for the rest of your day. And if you are interested in peak analysis, please come back at 2. Thank you.